Welcome back. Today we're going to talk about inequalities with one variable. And so the first thing I want to do is review the inequality symbols. So this first symbol here is called a greater than symbol. Some words that you can use to, some words that would translate into the symbol is more than, is greater than, is larger than, or above. This right here is the less than or equal to symbol. So some words that would greater than or equal to symbol. So there's some words that would translate would be minimum, at least, is not less than, no smaller than. So for instance, if you say the minimum price for an object, you'd say X has to be greater than or equal to, let's say, $20. So the smallest it's ever going to get is $20 because X is greater than or it's equal to $20, but it's no less than $20. Okay, the next symbol is a less than symbol. So some words that translate into strictly less than. And when I say strictly, it means that it can't be equal to. Okay, so I'll say strictly less than. That means that you're using this symbol as opposed to the less than or equal to symbol. Is smaller than, is less than, or below, all are things that can translate. So if something's smaller than a certain amount, that means that they can't be equal to that amount. Okay, or if it's less than that, then it can't be equal to it. Less than or equal to, so this is this inequality is not strict. Maximum, at most, no more than, and is not greater than. So this is a very handy chart in order to translate verbal inequalities into the symbols that are needed to express them algebraically. Okay, this is a review from 7th grade of graphing inequalities. So if I say that a number is less than 3, then I want to create an open circle at 3 and shade to the left. So I can indicate my shading like this, and I want to always bold in the arrowhead that's on the same side. So what I've done is I've shaded all the possible values that I could substitute in here for X and have the inequality to be true. So for instance, I shaded in the value of 0.5. So it is true that 0.5 is less than 3. Notice it's an open circle because it's a strict inequality. So I can't include the value of 3, so I don't shade it in. Whereas this one is going to be a closed circle at 3 and shading to my left here. And always bold in my right. So the difference between these two is that this became not a strict inequality and this made it a closed circle. If X is equal to 3, then the only value that can be put in there to have this equation be true would be 3, because 3 is the only thing that's equal to 3, so you only put a dot at 3. X is greater than 3 is an open circle at 3, and you shade to the right, remembering to boldface the arrowhead, indicating that that values to the right of those shown in the number line here can be substituted in for X. And here you're going to have a closed circle at 3 and shading to the right. Okay, so these are all the combinations of the different types of shading and closed and open circles that you can use. Okay, one property of inequality that we should go over is the transitive property. So if one number is less than another number, and that second number is less than a third number, then the first number is absolutely less than the third. So for instance, if 1 is less than 5, and 5 is less than 10, then we know that 1 is less than 10. That's what we're saying here. Okay? Okay, another property, these are other ordering properties. So if we know that X is less than Y, then what we also know is that negative X is greater than negative Y. So for instance, I'm going to give you an example up here. Let's say that we have numbers 3 is less than 5 here. Okay, so X is equal to 3 in this situation and Y is equal to 5. So if 3 is less than 5, which it is, we know that negative 3 is greater than negative 5 because that's the way that negative numbers work. The larger the magnitude of the number, the smaller the number, the bigger the number actually is in terms of negative. So this negative 3 has a magnitude of 3, negative 5 has a magnitude of 5. This one is less negative than this one, so it's greater than, negative 3 is greater than negative 5. Likewise, if you reciprocate, so if you have 1/3 and 1/5, right? This is 1 over the original value of X and 1 over the original value of Y. If you reciprocate them, then you know that originally, if 3 is less than 5, you know that 1/3 is going to be greater than 1/5. So two things force the inequality to flip around. That is multiplying by a negative number and reciprocating them. Either one of these things require you to flip around the inequality that you're using. You're first using the less than symbol, then now we're using the greater than symbol in these two examples here. Okay, this is going to come in handy when we are solving inequalities, those two ordering properties. So let's solve and graph these inequalities. I'm going to push this down a little bit here. So here, when you solve inequalities, you want to solve them just like equations, where you're trying to isolate the variable. You can do the same things that you did before, with one or two exceptions. Here, 31 minus 4 is 30 minus 3, which is 27. Now here, when I divide by -3, I want to make sure anytime I divide or multiply by a negative number, I have to flip the inequality around. So here I have x is greater than or equal to -9. Okay, so here make a note that you flip this inequality around because you divided by this -3. Okay, if you're dividing by a positive number, you don't have to flip it around, but it's only when you have a negative number. So when you graph this solution, what I want you to do is put -9 in the middle, and I want you to put the two numbers on either side of -9. Okay, and this was going to be a closed circle, and we're going to shade to the right because we want all the values that are to the right here. Now, interval notation is another way of expressing. This is the new thing that you're learning right now in this lesson, because all this stuff is from 7th grade. Interval notation is the new thing. It's a way of expressing the values using an interval of numbers. Okay, so the values that can be substituted in for this inequality that would make it true are values like -9, -8, -7. These are just the integer values, but of course there are values in between here like -8.5, -7.5. So all these values up until infinity. So I am going to express this using intervals. Okay, so intervals are a way to express ranges. Now, I'm allowed to include -9, so I'm going to use this square bracket here, okay? The square bracket means I'm allowed to include the value. So I have -9, and this is my lower bound. The left number in the interval notation is going to be your lower bound. Now, the numbers that I can put in here are, could be, you know, a billion, a trillion, you know, a quadrillion, a quintillion, any of those numbers I can put in here. They go so far up that they go into, we say they go to infinity, so I use the infinity symbol. Now, when I use the infinity symbol, this is a very theoretical argument, but I never use the square brackets with an infinity symbol. I always use a rounded bracket. Okay, so the interval notation, this is something new, so I understand we're gonna do a couple more examples with these so that you're comfortable with it. This is the same way of expressing the information that you see on the graph above. So let me just put this here. Let me move this around for a second. So this is the same way as expressing this information. It's just using intervals. The closed circle goes to a square bracket. And if your arrowhead is going off to infinity, then you use a rounded bracket. So this means that any of the numbers between -9 and infinity, I can replace in for x in the original inequality to make the inequality true. Okay? All right, let's go on to another example. So we're going to solve, graph, and express with interval notation. So to solve this, the first thing I'm going to do is distribute. We have 4x minus 16 minus 8x is less than or equal to 0. Let's add these two together to get -4x minus 16 is less than or equal to 0. Add 16. We have -4x is less than or equal to 16. Divide by -4. So again, we need to flip the inequality around. X is greater than or equal to -4. So in this case, I want to graph it. So we have -4. We'll put -3 here and -5 here. We want to close circle at -4, and we want to shade to the right. So I'm going to use a closed bracket because I can include the value of -4 here, and I want to put a comma, and so this is the lower bound, the minimum number that I can put in here for x. Square bracket means I can actually include that minimum number. And it goes up to infinity as indicated by this arrowhead, and I want to use a rounded bracket here, okay, just a parenthesis symbol. Okay, so some of the symbols that we use in this lesson are shown here. Some of the symbols some of them we haven't used in the lesson, but I want to review with you, or I want to explain to you. If you have a less than or equal to symbol, like if you end up having, let's say x is less than or equal to a value 3, then what you're going to have is a closed circle and shading to the left. Okay, so that's 3. And your minimum value is actually going to not be positive infinity like the greater than or equal to where we landed on before, but it's actually going to be negative infinity. Okay, so the lowest number that you can get to is a number called negative infinity. It's literally the opposite of positive. It's, you know, this is the integer value, where this is the whole number, right? This is the opposite of the whole number, infinity. Negative infinity is the smallest possible number. So you're going to use a rounded bracket there. So the smallest possible number is this really, really tiny, or really, really negative number, right? Whereas this n here would have been 3. So you're going to include the upper bound here, and that's going to be a square bracket. Square brackets always go with closed circles here. Whereas if you just have a strictly less than, you're going to use 2 rounded brackets here, and your lower bound is going to be negative infinity, comma, whatever the number is here that it's less than. Okay? If it's equal to, it's just going to be a dot. You're just going to have 2 square, your bounds are just going to have 2 square brackets, meaning you can only include this value n. If you have a greater than or equal to, like we've seen before, if this is your n value, then your lower bound is going to be n, and you can use a square bracket for it. Your upper bound is going to be the number infinity with a rounded bracket. And if it's just strictly greater than, then you have 2 rounded brackets, and you have n is your lower bound and infinity is your upper bound. You use a rounded bracket to indicate that you're not allowed to include n in this equation. Okay? And that is the end of the lesson for today. So we're going to do plenty of practice on this. I know you might not feel comfortable with the interval notation yet, but what I would just want you to understand is that, you know, whenever you have an infinity symbol here, whenever it's going to the right here, you have an infinity symbol. Whenever you have an infinity symbol, you use a rounded bracket. When it's going to the left here, then you're going to have negative infinity, and you're going to have this rounded bracket here, right? Whenever you have a closed circle, you're going to use these square brackets here, okay? And whenever you have an open circle, you're going to use the rounded brackets. So open circle means rounded brackets. Okay, so those are some things, some patterns to notice here. All right, and that is the end of the lesson for today.